ProGeneric's Parallel Template Library, or PTL, is a generic and parallel programming library for .NET and Java developers. PTL's Containers component offers powerful data containers that have been optimized for parallelism to take advantage of multicore processors. In this video, we'll demonstrate the performance of PTL's map container for large datasets by comparing it to the equivalent .NET SortedDictionary container. During the demo, we'll add, retrieve, and remove elements from both containers. A map is a variable size collection of key-value pairs. Its primary usage is the efficient retrieval of elements or values based on their associated keys. It also implements the insertion and removal of elements very efficiently. PTL offers Map32 and Map64 classes that are very similar to the .NET SortedDictionary class. PTL maps differ from the .NET SortedDictionary because they have a Boolean property called unique that is set in their constructor and indicates if the map allows or disallows duplicate keys. The .NET SortedDictionary only allows elements with unique keys. It's also important to note that PTL's Map32 and Map64 are not tuned for a 32 or 64-bit operating system. They only differ in their maximum size. We use the .NET SortedDictionary and the PTL Map32 containers in this demo. In this demo, both maps will contain map entry values, which are key-value pairs. The size of a map entry object is 16 bytes, 8 bytes for the key and 8 bytes for the value, and it's a value type or a C# struct, so there is not a reference associated with each entry. We also use the map entry data type across other demos for consistency to make it easier to compare results. Previously, we filled an array with 100 million numbers from 0 to 100 million minus 1, randomly shuffled them, and stored them to a file. We use this file to load both the .NET SortedDictionary and PTL Map32 objects with map entry values, and we use the next random number for both the key and the value for each map entry element. This allows us to compare the results using the same data. We'll run our demo application on a system with one Intel Core i7 processor that has 4 physical cores or 8 logical cores with hyperthreading and 32 gigabytes of memory. We'll also restart the demo application after each test to run each test independently and get a fair comparison. First, let's add 100 million elements, or key-value pairs, to an empty .NET SortedDictionary object. Now we'll fast forward to when the insertion has finished. The average speed was around 249,000 elements per second, and it finished in 6 minutes and 42 seconds. While we still have the dictionary in memory, let's retrieve each value based on the key. We'll read the keys from the same file that we used for insertion. We'll fast forward to when the item or indexing operation is done. It finished in 2 minutes and 31 seconds with an average speed around 662,000 elements per second. Next, let's remove all of the elements from the dictionary in the same order that we inserted them. Again, we'll fast forward to when the remove operation has finished. It took 4 minutes and 2 seconds with an average speed around 413,000 elements per second, which was faster than the insert operation. Now we'll perform the same operations for a PTL Map32 object using exactly the same data. First, let's also insert 100 million pairs into an empty PTL Map32. Now we'll fast forward to when the insertion has finished. It finished in 1 minute and 47 seconds, with an average speed around 935,000 elements per second, which was 3.8 times faster than the add method of the .NET SortedDictionary. While we still have the map in memory, let's retrieve each value based on the key. Again, we'll read the keys from the same file that we used for insertion. We'll fast forward to when the item or indexing operation is done. It finished in 1 minute and 11 seconds, with an average speed around 1.4 million elements per second. It was 2.1 times faster than the indexing operation of the .NET SortedDictionary. Finally, let's erase all of the elements from the map in the same order that we inserted them. Again, we'll fast forward to when the erase operation has finished. It took 1 minute and 26 seconds, with an average speed around 1.2 million elements per second, and it was 2.8 times faster than the remove function of the .NET sorted dictionary. These tests have demonstrated that the insert, retrieve, and erase functions of PTL's Map32 have much faster performance than the equivalent functions from the .NET sorted dictionary. The PTL map classes are well designed to sustain large datasets. We'll demonstrate in another video a more efficient way of building maps from scratch. If you're ready to test PTL's containers yourself, click here to download our free trials. PTL offers many more containers and algorithms with excellent parallel performance, which are discussed in other videos. You can also learn more about PTL on our website, where you can read its documentation and view more demos and code examples.